November 1941, rural Pennsylvania. 2 in the morning. A black government car rolls to a stop on a dirt road at the edge of a private estate. The driver kills the headlights. For a moment there is nothing but darkness and the sound of wind moving through bare oak trees. The rear door opens. A man steps out. 62 years old, heavy coat, good shoes, the wrong shoes for what comes next. He looks out across the field in front of him. Somewhere beyond the fence line, beyond the darkness, something is running. He can hear it before he can see it. A deep mechanical groan, a rhythmic percussion that rises up through the ground and into the soles of his feet. He starts walking. No flashlight, no aid beside him. Just Harold Marsh, United States Secretary of the Navy, walking alone through ankle-deep Pennsylvania mud toward a sound that has lived in his head for 25 years. He walks nearly a mile. He never looks back at the car. You need to understand something before this story goes any further. Harold Marsh did not come to Pennsylvania that night to inspect a naval project. He did not come to review a weapons test or authorize a budget or show his face for the cameras. There were no cameras, there was no press release, there was no official record that this visit ever happened. He came because he had to see it with his own eyes. Because Harold Marsh had spent the better part of his adult life living with a failure that most men would have quietly buried and forgotten. He had not forgotten, he had carried it the way certain men carry certain things, not as a burden exactly, but as a fixed point. A piece of unfinished business that waited for him every morning when he opened his eyes. And in the darkness ahead of him, obscured by mud and fence wire, and the Pennsylvania winter, that unfinished business was finally about to become real. Go back to 1916, go back to the Western Front. Harold Marsh is not a soldier, he is 37 years old, a naval administrator attached to an Allied observation committee, and he has come to see how the war is going. He expects to be briefed in a dry room with maps on the wall and a colonel pointing at lines with a wooden stick. Instead, they take him to the front. What he sees there does not leave him for the rest of his life. 2 armies facing each other across a strip of ground that varies between 50 and 300 yards wide. No man's land, a name that has become accurate in every possible sense. The earth has been so thoroughly destroyed by 4 years of artillery that it no longer resembles Earth. It is a grey-brown lunar surface pocked with craters filled with freezing water, threaded through with rusted wire, scattered with things Marsh forces himself not to look at directly. And into this ground men walk, not charge, not advance boldly with bayonets and flags. They walk because the terrain does not allow running. They walk in straight lines because the officers have told them to dress their lines, and the machine guns on the German side cut them down in those straight lines, and behind them other men step forward into the same straight lines, and the machine guns cut those men down too. Marsh watches this for 40 minutes. He does not speak on the drive back. He does not speak at dinner. He sits in his billet that night and writes in his notebook, not an official report, not a memorandum, just a question, written in pencil, underlined twice. Why does no machine do this instead? Within a week, he has the beginning of an idea, a mechanical trench cutter, something armored, something that moves under its own power, across open ground and carves a protected pathway through the earth fast enough to matter, a machine that does what men cannot, absorbs the bullets, moves through the wire, delivers an infantry force to the enemy line with something resembling a fighting chance. He puts the idea into a formal proposal. He routes it through the proper channels. He argues for it in 2 separate committee meetings, facing men with more rank and more years who look at his drawings the way experienced people sometimes look at things that threaten their understanding of how the world works. The proposal is rejected, not debated at length, not shelved for further study, rejected. The committee chairman tells Marsh, not unkindly, that the ground conditions of the Western Front make mechanized excavation impractical, and that the strategic situation does not support the development timeline such a project would require. He thanks Marsh for his thinking and moves on to the next item. Marsh takes his drawings and walks out. The war ends 2 years later. The final tallies come in. Over 1 million British dead, over 1 million French dead, American losses approaching 120,000 in just 19 months of involvement. Hundreds of thousands of those men died, crossing open ground that a machine might have crossed for them. Marsh keeps his notebook, he keeps the drawings, he keeps the question. Time passes the way it does, careers are built, governments change. Harold Marsh rises through the civilian administration of American naval power. Not a man of the sea himself, but a man who understands systems, budgets, the machinery of institutional decision-making. He is good at his work. He is known as precise, relentless, occasionally difficult. People who work for him respect him without particularly warming to him. He asks too much. He remembers everything. In September 1939, he returns to a position of real authority as Secretary of the Navy under a president who understands that American involvement in the European war is a matter of when, not whether. Marsh sits at his desk in Washington on the morning of September the 4th and reads the intelligence summaries with the focused attention of a man whose nightmare has just been announced publicly. Germany has constructed the Siegfried Line, a continuous belt of fortifications running along the western German border, concrete bunkers, anti-tank obstacles, interlocking fields of fire. France shelters behind the Maginot Line, that vast, fixed fortress of steel and cement running along the Franco-German frontier. Two armies, separated by a strip of contested ground, facing each other across prepared positions. The map looks different from 1916. The weapons are more sophisticated, the armies are motorized, but the fundamental geometry is the same. Marsh looks at the map for a long time. Then he opens the bottom left drawer of his desk, reaches to the back, and takes out a notebook he has carried from office to office for 23 years. He opens it to the page with the penciled question underlined twice. He picks up his telephone. Here is the part of the story that most people would not predict. Harold Marsh does not call the army. He does not route his proposal through the Department of War. He does not convene a joint committee or request an inter-service feasibility study or do any of the things that the American military bureaucracy of 1939 would normally require. He has been inside that bureaucracy long enough to know exactly what it does to ideas that challenge its assumptions. He saw what it did to his idea in 1916. He has watched it happen to other ideas in the years since. Good ideas, necessary ideas. Ideas that arrived in a committee room full of cautious men and never came out again. He is 60 years old. He does not have time for that process. So Harold Marsh does something that is, depending on your perspective, either an act of inspired institutional creativity or a fairly serious abuse of his authority. He routes the entire project through the Navy, a trench-cutting machine for Army infantry funded by naval appropriations, designed by naval engineers, administered by the newly created Department of Naval Land Equipment, a bureaucratic entity that Marsh essentially invents on the spot to give the project an institutional home that the Army cannot touch. No Army general is consulted, no Army committee reviews the proposal, no one in the Department of War is informed that this project exists. When a subordinate points out that this arrangement is, at minimum, procedurally irregular, Marsh looks at him with an expression that contains no uncertainty whatsoever. "Find me a regulation that specifically prohibits it," Marsh says. There isn't one. He assigns technical oversight to Rear Admiral Clifton Merritt, a naval constructor, methodical and precise, the kind of man who double-checks calculations that other engineers have already triple-checked. Merritt does not share Marsh's urgency or his accumulated grievance. What he shares is a professional commitment to solving whatever problem is placed in front of him. Merritt recruits Frank Weston, 28 years old, marine engineering degree. The kind of young man who fills notebooks with mechanical sketches during meetings and genuinely cannot understand why other people find his level of focus unusual. Marsh meets Weston once, briefly, in a corridor outside Merritt's office. He looks at the young engineer for a moment without speaking. "You understand this project does not exist," Marsh says. Weston understands. The team establishes itself in the most improbable of locations. The lower level of the Greenbrier Hotel in White Sulphur Springs, West Virginia, which has been partially requisitioned for wartime government use. The main hotel continues operating above them. Guests take the waters and play cards in the grand rooms upstairs, while, in the wine cellar directly beneath, Frank Weston and a small team of engineers spread their blueprints across wooden tables and begin designing the most unconventional weapon in American military history. By December 1939, a working-scale model exists. 1:20 ratio, built by a model fabrication firm in Dayton, Ohio, that has been told only that this is a government contract requiring absolute discretion. The model runs on a small electric motor. When operated in simulated soil, a mixture of sawdust and modeling clay packed into a wooden tray, it works exactly as designed. A tiny trench forms behind it. Perfect proportions, consistent depth. The model is packed into a wooden case for transport to Washington, where Marsh has arranged a private demonstration for the most senior officials in the administration. The wooden case is the right length and width to contain a child's coffin. On the platform at the rail station in Dayton, 2 government employees carry it through the public waiting area toward the government car that will take it to the train. They move quickly, heads down, wanting to attract no attention. They attract considerable attention. A woman in a grey coat stops walking. She removes her hat. A man nearby does the same. Within 30 seconds, 8 or 9 people in the waiting area have gone still and quiet, hats in hand, heads slightly bowed, the way Americans stand when a small casket passes. Nobody speaks, nobody asks. They simply assume and they pay their respects. And the 2 government employees walk faster and say nothing, and the case goes into the car and the car pulls away. The story circulates through the project team within a week. Engineers and draftsmen who have been working in a wine cellar for months, who cannot tell their families what they are doing or why, who are building something that may not work toward an outcome that cannot be spoken aloud. They find in this story something they need, a dark joke with weight to it. The machine had a funeral before it had a test. The project started as a burial. Some of them think this is funny. Some of them think it means something. Harold Marsh, when he hears the story, says nothing. But the people who are in the room when he hears it remember that he is quiet for slightly longer than usual, and that when he starts speaking again, his voice is different, quieter, more certain. The demonstration takes place in a private room in Washington. The model is placed on a table. The simulated soil is arranged. Marsh stands to one side while the model runs its course, producing its neat miniature trench, depositing its miniature spoil banks on either side. The senior officials in the room watch in the silence of powerful men who do not yet know whether they are witnessing something important. When the model completes its run, Marsh speaks. He does not talk about the engineering. He does not lead with specifications or projected production rates or cost estimates. He talks about 1916. He talks about what he saw on the Western Front. He talks about the geometry of open ground and what it costs in human terms when men have no choice but to cross it on foot. He talks for 4 minutes. Then he stops. Nobody in the room speaks immediately. One official picks up his pen and puts it down again. Another looks at the small trench in the simulated soil and appears to be calculating something private. Approval comes within the week. Production authorization follows in February 1940. 240 machines. The target is 20 per week, an order of industrial ambition that matches the scale of what Marsh has been imagining for a quarter of a century. Outside, the war in Europe is shifting, German armor is moving, but in Washington, and in the wine cellar of a resort hotel in West Virginia, and in the offices of a heavy excavation equipment firm in Milwaukee, a machine is being born. Harold Marsh drives back from the authorization meeting alone. His driver asks if he wants the radio on. Marsh says no. He looks out the window at the winter streets of Washington, and for the first time in many years, the question in the notebook does not feel like an accusation. It feels like an answer that is finally, irreversibly, on its way. January 1940, Milwaukee, Wisconsin. The WWII company has been building heavy excavation equipment since 1880. Steam shovels, cable cranes, the kind of machinery that moves mountains one bucket at a time. Their plant on South First Street is a cathedral of industrial noise, the smell of hot metal and cutting fluid, the percussion of stamping presses, the organized chaos of men who build things that dwarf the men who build them. Frank Weston walks through the main floor on his first visit and stops in the middle of the aisle. He stands there for almost a full minute, looking up at the overhead cranes, at the half-assembled dragline buckets, at the sheer scale of what this facility is capable of producing. A foreman almost walks into him from behind. Weston doesn't apologize. He is already doing the math in his head. The contract has been signed. 240 machines. The production target is 20 per week once the line is running. The numbers are staggering even by wartime standards, and the men at WWII who have been quietly briefed on the project dimensions are staggered by them. A machine 77 feet long, 130 tons, moving parts operating simultaneously under armored protection at a dig rate of half a mile per hour. Nothing like it has ever been built. Weston goes back to the Greenbrier that evening and works through the night. The design at this stage is built around a specific engine, the Allison 51710, a liquid-cooled V-12 aircraft power plant producing around 1,000 horsepower, already in production for American fighter aircraft. It is powerful enough, compact enough, and available enough. Also, Weston believes when he incorporates it into the primary design schematics in late January 1940. He spends the next 8 weeks building the entire mechanical architecture of the iron mole around that engine. The power transmission, the cutting drum ratios, the conveyor belt timing, the hydraulic systems, every calculation downstream flows from the assumption that 2 Allison 51710s will sit in the machine's engine bay and drive the whole system. In late March, Merritt receives a letter from the Army Air Force's Procurement Office. The V-1710 is unavailable for non-aviation applications. Demand from P-38 and P-40 production has consumed current and projected output for the foreseeable future. The request is denied. Merritt reads the letter twice. Then he walks down 2 corridors and knocks on the door of the room where Weston is working. He slides the letter across the table without speaking. Weston reads it. He sets it down. He looks at the wall of technical drawings in front of him. 8 weeks of 18-hour days, rendered in precise pencil lines on drafting paper. Every drawing connected to every other drawing. A complete mechanical world built on a single assumption, and the assumption has just been removed. He picks up his eraser. This is the point where lesser projects die. When a central assumption collapses, the momentum reverses. The people involved begin quietly updating their resumes. The official communications become more formal and more infrequent. Eventually, someone writes a memo recommending suspension pending further review, and the project goes into a file, and the file goes into a cabinet, and the cabinet goes into a room that nobody visits. Harold Marsh is informed of the engine situation on a Tuesday morning. By Tuesday afternoon, he has called Dr. Samuel Briggs, an independent power plant consultant who has spent 20 years working on diesel applications for marine and heavy industrial use. Briggs is not glamorous. He is not associated with fighter aircraft or speed records or anything that appears in newspaper photographs. He is a man who makes large, ugly engines work reliably under terrible conditions, and that is precisely what Marsh needs. Briggs arrives at the Greenbrier on Thursday. He spends 2 days reviewing Weston's drawings, asking questions, and filling a legal pad with his own calculations. On Saturday evening, he sits down with Marsh and Merritt and delivers his verdict without preamble. 2 Fairbanks Morse 38D diesel engines, each rated at 600 brake horsepower. Together they produce less raw power than the rejected Allisons, but the Fairbanks Morse carries something the aircraft engine does not: a modular construction architecture that allows components to be manufactured independently across multiple facilities and assembled at a central point. In practice, this means the engine can be built in pieces by suppliers who never see the whole. More than 400 subcontractor firms across the United States can produce components simultaneously: gears, casings, fuel systems, cooling jackets, without any single firm understanding what it is contributing to. The secrecy of the project is preserved. The full production capacity of American industry is mobilized without any single factory knowing why. The consequence, however, is that the machine must grow. The Fairbanks Morse installation requires more space than the Allison. The modified engine bay forces a redesign of the surrounding structure. The surrounding structure forces a redesign of the conveyor system. The conveyor system forces a redesign of the cutting drum housing. By the time the cascade of engineering changes works through the full schematic, the iron mole is longer, taller, and heavier than anything in the original specification: 130 tons, 77 feet stem to stern, 8 months behind schedule. Marsh approves every modification without hesitation. Weston rebuilds the drawings from scratch. He works with the intensity of someone converting frustration directly into precision. The new design is more complex than the original, and the problems it poses have no precedent in any engineering handbook, because no engineering handbook has ever needed to address this specific problem. He works around them one by one. The finished machine operates as follows. A large angled plow blade at the front attacks the upper half of the soil, pushing it sideways and upward. Behind and below it, a rotating cutting drum, spinning perpendicular to the direction of travel, removes the lower half. The combined action produces a clean trench 5 feet deep in a single pass. Long conveyor belts carry the excavated soil rearward along the top of the machine and deposit it in banks on either side, rising 2 to 3 feet above ground level. A soldier, standing in the finished trench, has close to 8 feet of earth between himself and direct fire. The machine runs on tracks that wrap entirely around its body, the same rhomboid configuration used on the tanks of the First World War, chosen because it distributes the enormous weight across the maximum possible ground contact area. A crew of 3 operates from an armored conning tower. 1 drives, 1 monitors the mechanical systems, 1 navigates. Digging speed, 0.5 mile per hour, displacing approximately 8,000 tons of soil across that distance. Surface travel without digging, just over 3 miles per hour forward, 1.5 in reverse. The official designation is Cultivator Number 6. The project team calls it NEL. Nobody records why. It is simply what it becomes. May 1941. The prototype is completed at the Bucyrus-Erie Works in Milwaukee. Shop trials begin on the 4th of that month. Engineers run the cutting systems under load. The conveyor belts move, the tracks engage. The diesel engines produce their deep, authoritative vibration. A sound that Weston, standing on the factory floor with his hands in his pockets, will later describe as the most satisfying thing he has ever heard. In late June, the machine is disassembled into 3 sections for transport to the private estate in Pennsylvania. The transport requires specialized trailers engineered specifically for these loads. Moving 3 sections of NEL from Milwaukee to Pennsylvania is itself a minor logistical operation, conducted at night over several weeks. The 769th Company of Army Engineers assembles the machine on site. Most of them do not know what they are assembling or why. They follow the technical drawings, they fit the pieces together. When Nell stands complete in the Pennsylvania field for the first time, the sergeant in charge of the assembly team walks slowly around the perimeter and does not speak for a long time. Then he says, to no one in particular, "Well, all right then." August 15th, 1941, formal demonstration for the Army General Staff. The senior officers who have traveled to Pennsylvania for this event arrive with the composed skepticism of military men required to evaluate something they already disapprove of. General Arthur Holt, Assistant Chief of Staff, 58 years old, a man whose every professional instinct runs toward the proven and the controllable, stands at the edge of the observation area with his arms crossed and his face arranged in careful neutrality. Nell moves forward. The plow bites into the Pennsylvania soil. The cutting drum engages. The conveyors begin their cycle. And a trench forms behind the machine, clean-walled, consistent depth, exactly to specification, unrolling across the field the way a zipper opens a seam. Nobody on the observation line speaks. The machine is loud. It shakes the ground noticeably at 30 yards. The spoil banks rise with mechanical regularity on either side of the advancing trench. The movement is slow, deliberately, precisely slow. And there is something in that slowness that makes it more impressive rather than less. This is not a machine that is rushing. This is a machine that is inevitable. Holt watches for 20 minutes. He does not unfold his arms, but somewhere in the second half of the demonstration, his expression shifts in a way that is very small and very significant. The studied neutrality becomes something that is working harder, something that has encountered more than it expected and is not yet ready to say so. September 12, 1941. The minefield test is not officially on the demonstration schedule. It is added at the suggestion of an Army ordnance officer who wants to understand how the machine interacts with buried explosive devices. Specifically, whether Nell will detonate contact mines and destroy herself and her crew before she reaches the enemy line. 16 anti-tank mines are buried in a test field according to standard military spacing, real mines, fully armed. Nell enters the field. The observers step back from the perimeter fence without being asked. A heavy, waiting quiet falls over the group. The silence of men watching something that may explode. Even Holt, who has seen combat and does not consider himself susceptible to theatrical tension, moves back a half step without appearing to notice he has done it. The machine moves through the field. The plow and cutting drum churn through the buried mines, extracting them, depositing them onto the conveyor system, dropping them into the spoil banks on either side of the trench. 16 mines enter the ground ahead of Nell. 16 mines appear in the spoil banks behind her. Not one detonates. The ordnance officer walks into the trench and examines the recovered mines personally. They are intact, extracted rather than triggered. The mechanical action of the cutting drum apparently passing beneath the pressure-sensitive fusing mechanisms without applying the vertical force required to initiate detonation. Then the ordnance officer looks at the spoil banks. He calls for everyone to stay clear. The mines are in there somewhere. The trench itself is safer than the ground beside it. A fact so counterintuitive that it takes a moment to fully resolve. A machine designed to advance on an enemy position has just made the safest place on the battlefield the path it left behind. Holt opens his notebook. He writes for a moment. He closes it. He will not openly support the project. That is not who he is, and not what his professional judgment allows. But that evening on the drive back, one of his aides asks what he thought. Holt looks out the window. "It works," he says. "Whatever else you want to say about it, the machine works." November 6th, 1941. Harold Marsh arrives in Pennsylvania at 2 in the morning and walks a mile through mud that pulls at his shoes with every step. He is 62 years old and has not slept on the drive from Washington and does not feel any of it. He reaches the perimeter fence and stands there while Nell runs her demonstration pass. The floodlights throw long shadows across the field. The conveyor belts move in their steady rhythm. The trench forms and extends and the spoil banks rise, and the night smells of diesel exhaust and overturned earth. Marsh watches without speaking. His hands are in his coat pockets. His face holds an expression that the two aides standing behind him have not seen before and will not see again. He watches for 40 minutes. When the machine stops, he walks alone along the edge of the trench. 7.5 feet wide, 5 feet deep. Clean walls. A man could walk the length of it upright, in full kit, sheltered from direct fire on both sides. He crouches at the trench edge and picks up a handful of the turned soil and looks at it. Then Admiral Merritt approaches with General Holt, and Holt is carrying a document. Marsh stands, he drops the soil, he brushes his hands together slowly. Holt opens the document and begins to speak. The first thing he addresses is the turning radius. When the cutting system is engaged, the mechanical forces make any significant change of direction functionally impossible. The minimum turning radius approaches 2 miles. In practical terms, every trench Nell produces is a straight line, and a straight line in a contested theatre with active air power is a targeting vector, a reference corridor for dive bombers. The straighter and more visible the trench, the more efficiently an air attack can follow it from end to end. Marsh listens without expression. Then Holt delivers the second point. "Mr. Marsh," he says, and his voice carries the quietness of a man delivering information he takes no pleasure in delivering. France fell 17 months ago. The Wehrmacht is in Paris. The Siegfried Line is no longer a barrier we need to penetrate. It is a fortification behind a front that no longer exists in the form we planned for. This machine was designed to break a Western Front stalemate. That stalemate did not materialize now. He pauses on the war we built this machine for did not happen. The field is quiet except for the cooling tick of Nell's engines. Marsh stands at the edge of the trench he has spent his career trying to build, in the field where it finally, undeniably works, and says nothing for a long time. The Pennsylvania mud is drying on his shoes. The diesel exhaust drifts sideways in the cold air. The machine that does everything it was designed to do sits in perfect mechanical readiness behind him, waiting for a war that moved on without it. The memoranda begin the following week. Marsh does not call a meeting. He does not convene a review board or request a formal strategic reassessment. He sits at his desk on a Monday morning and writes the first reduction order himself, in longhand, the way he writes things he does not want filtered through a secretary. 240 machines, he crosses out the number, he writes 120, he caps his pen, he signs the document, he places it in the outbox, then he opens the next file on his desk and gets back to work. This is how Harold Marsh processes things. Not through extended reflection, not through conversations in moving vehicles, through the next decision and the one after that, and the discipline of keeping his attention on what can still be controlled. He has been this way since 1916, and he does not expect to change now. But the number in the outbox keeps moving. 120 becomes 60, 60 becomes 33. Each reduction is a signature on a separate document. Each document reflects the same strategic logic. The fixed front engagement that Nell was designed to break has not materialized, and the probability of it materializing in time to matter grows smaller with every week of the war's actual development. The Army General Staff, emboldened by the strategic assessment and their own long-standing skepticism, formally requests complete suspension of production following the August demonstration. The request lands on Marsh's desk. He reads it, he sets it aside. He does not approve it. His staff watches this with careful attention. They have learned to read the space between his decisions. Marsh is not approving the suspension. He is not rejecting it outright. He is holding it, the way a man holds something he knows he will eventually have to put down, but has not yet found the right moment for. Admiral Merritt understands before anyone else does. In his private correspondence during this period, he writes to a colleague with characteristic precision. He knows the project is finished. He has known since November. He is giving himself time to know it all the way through before he acts on it. Frank Weston keeps working. This is perhaps the most quietly remarkable element of the project's final phase, that its youngest member, the engineer who has no 25-year history with the idea and no personal mythology attached to the outcome, continues refining the design through the winter and into 1942. He modifies the cutting drum geometry to handle heavier clay soils. He redesigns the conveyor tensioning system to reduce the jamming risk the August trials revealed. He submits detailed proposals for a revised turning mechanism, not a solution to the fundamental radius problem, which remains intractable, but a marginal improvement that would allow Nell to deviate perhaps 10 degrees from a straight line over the course of a quarter mile. Nobody asks him to do any of this. When Merritt gently raises the question of whether this work is the best use of Weston's time, given the project's current status, Weston looks at him with the focused expression of a man confronted with a question he considers slightly beside the point. "The turning radius is still wrong," Weston says simply. Merritt considers this. "Frank," he says, "the project may not continue long enough for the turning radius to matter." Weston nods slowly, as if he has heard and processed the information and found it genuinely insufficient reason to stop. He goes back to his drawings. There is something in this that Marsh, when he hears about it, does not dismiss or find absurd. He understands it better than Merritt does. When a man works on a problem long enough, it stops being about the original reason. It becomes its own reason. The machine demands completion regardless of whether the completion will be used. He has spent the better part of his professional life feeling exactly this way. The war reshapes itself through 1942 and into 1943 in ways that confirm what Holt said in Pennsylvania at every turn. North Africa, the Pacific, the Eastern Front consuming men and material on a scale that makes the trench warfare of 1916 look like a border skirmish. This is not a war of fixed positions and contested strips of ground. It is a war of movement, armored columns crossing hundreds of miles in days, amphibious assaults on defended coastlines, air power applied at operational scale, logistics chains stretching across oceans. The Iron Mole is a machine built for one specific tactical problem: infantry assault across a short strip of open ground toward a fixed defensive line. The War of 1942 does not present that problem in any form that Nell can address. Marsh reduces the order to 9 machines, 9, from 240. He stares at the number for a moment before signing. Then he signs. May 1st, 1943. The cancellation order is a single page, written in the flat institutional language of government procurement, contract termination, project closure, disposition of assets. It does not explain what the project was. It does not contain a single word that could tell a reader, decades later, that this document ended something a man had carried across half his life. Marsh signs it in his office, alone on a Friday afternoon. His secretary has already gone home. The building holds the particular quiet of a Friday evening, not empty, but suspended, as if everything official has been set aside for the weekend, and the air has not yet decided what to do with the absence. He signs. He caps his pen. He places it parallel to the edge of the document, precisely, deliberately, a small order imposed on a desk that has just received a large disorder. Then he picks up a separate sheet and writes a short addendum by hand. Keep the 4 infantry-type machines in good working order. Their turn may come. He is not certain he believes this. He may not believe it at all. But he writes it because Harold Marsh has spent his entire professional life at the intersection of what is practical and what is necessary, and there is a version of necessity that does not yield cleanly to practicality, that insists on keeping the door open even when every reasonable assessment says the room behind it is empty. He folds the addendum, he places it in the file, he takes his coat from the rack and walks out. The surviving machines are moved to a storage depot and maintained per Marsh's written instruction. Nell sits in her shed while the war continues to evolve around her. While other machines and other ideas absorb the energy of American production, while the strategic map of the world reorganizes itself in ways that leave no operational space for a 77-foot trench cutter moving at half a mile per hour. When the war in Europe ends in May 1945, the remaining machines are disassembled. The work is done in part by German prisoners of war, men held in American camps pending repatriation, assigned to labor details as part of standard post-war administration. They take Nell apart with the methodical efficiency of people doing a job rather than witnessing a history, which is perhaps the appropriate way to dismantle something that history has already passed judgment on. Marsh, when someone mentions this detail to him later, is quiet for a moment. "Seems right," he says. He does not elaborate, but the people who are in the room when he says it understand that there is more behind those 2 words than the words themselves contain. The machine built in secret to break German fortifications, dismantled by German hands. He has thought about the geometry of things long enough to recognize when a circle has closed. He issues a preservation directive before leaving office. One example to be retained, maintained, placed in a suitable facility as a record of the engineering achievement. His stated reasoning is straightforward. His actual reasoning runs deeper. The sense that something which cost this much in years and effort and belief deserves to exist somewhere in physical form, even if only as evidence that it happened. After Marsh leaves office, the directive sits in the file without urgency. The engineers who understood the project have moved on. The institutional memory that gave the directive its weight has dispersed. The last machine is scrapped sometime in the mid-1950s. No surviving example of the iron mole exists anywhere in the world. Here is what does exist. In the spring of 1940, when the Army Air Forces refused to release the Allison FARB 1710, Frank Weston was forced to rebuild his engine specifications around the Fairbanks-Morse diesel. The Fairbanks-Morse was chosen because it was available, adequate, and, critically, because its modular architecture allowed it to be manufactured across more than 400 independent suppliers without any single supplier understanding the complete application. That modular architecture turned out to be extraordinarily well suited to a challenge the designers of the iron mole never anticipated, because they were thinking about trench cutting in 1940 and not about amphibious landings in 1944. The United States Navy, in the process of building the largest amphibious assault capability in the history of warfare, needed reliable medium-power diesel engines for landing craft infantry, landing craft tank. The vessels that would carry men and armor from ships to shore, across defended beaches at distances and in numbers the world had never seen attempted. The Fairbanks-Morse engine that Weston selected under duress in a West Virginia wine cellar in the spring of 1940 was adapted for marine use with relatively modest modification. Its modular construction, already optimized for distributed manufacturing, allowed production to scale with speed. More than 3,500 of these engines were built during the war. They ran in the landing craft of the United States Navy across both the Atlantic and Pacific theaters. They were present at Sicily, at Anzio, in the island campaigns of the Pacific, and on June 6, 1944, they were present at Normandy. The specialized transport trailers engineered to move Nell's sections from Milwaukee to Pennsylvania, built to carry loads that no standard military transport could handle, were adapted into 45-ton tracked recovery vehicles for heavy armor. The 79th Armored Division used them on the beaches of Normandy to recover disabled tanks under fire, keeping armored assets in the battle during the most consequential day of the war in the European theater. The machine built to end one kind of war helped win a completely different one. The trench that Harold Marsh first imagined in 1916 was never cut under fire. The Siegfried Line was breached eventually by means that had nothing to do with the iron mole. The stalemate he spent his career preparing to prevent did not materialize in the form he feared. But the engines of his failure ran across the water at Omaha Beach. They carried the men who ended the war. They were there in the grey light of that June morning, grinding through the surf, doing the essential work that Marsh had spent his whole career trying to find the right machine for: moving men across open ground to a defended shore. Not the machine he built, not in the way he imagined, but there, nonetheless, present, consequential, real. Harold Marsh's memoir, published in 1951, addresses the Iron Mole project in a chapter of 14 pages that is notably restrained by the standards of the book surrounding it. He discusses the engineering with precision. He discusses the strategic failure without self-pity. He discusses the cancellation without theater. Near the end of the chapter, he writes the line that has defined how people remember the project in the decades since: "I am responsible, but I am not sorry." 6 words on each side of a conjunction. The economy of a man who has thought about something for a long time and arrived at the clearest possible statement of a complicated truth. He made the decision. He drove it through institutional resistance that would have stopped most men before the first drawing was finished. He spent the money and the years and the authority he had built over a long career. The machine worked exactly as designed and failed for reasons entirely beyond the engineering. He is not sorry, because the question he wrote in pencil in a French billet in 1916 was the right question, even when the answer took a form he did not expect, because the attempt mattered, even when the ground shifted beneath it. Because a man who commits fully to an idea that almost succeeds has not wasted his years. He has spent them the only way certain kinds of men know how to spend them, which is completely against a problem that matters, without reservation. The Iron Mole sits in no museum. There is no placard, no scale model under glass, no record preserved for school groups on Tuesday afternoons. The men who built it are gone. The wine cellar in West Virginia has been renovated. The Pennsylvania field where Nell first moved under full power has been farmland for decades. What remains is the record. The engineering documents scattered across archives, the procurement files, the test reports, a single sentence in a memoir, and the indirect, invisible presence of a diesel engine in the hulls of the ships that crossed to Normandy. An engine chosen not because anyone planned it that way, but because a young engineer needed a solution under pressure and found one that turned out to be more durable than the problem it was designed to solve. Harold Marsh spent 25 years asking why no machine would do what men were being asked to do on the open ground of the Western Front. In the end, a machine did exactly that. It crossed the open water. It reached the defended shore. It delivered men into the fight. The question, in the only way that finally mattered, had been answered.